Hi everyone. In this session, I am going to be explain 01 Knapsack by using dynamic programming. I hope all you are good at what is an Knapsack problem statement. Once again, I want to recall the 01 Knapsack problem. Nothing but we have n number of items. Each item has its own profit and weight. We have one knapsack. Knapsack is nothing but a bag. When we have a bag, we know that bag capacity that we technically call a knapsack capacity. Our aim is we must select the given n set of n items. From the n items, we are going to be select some items. Those items placed into the knapsack. The knapsack always gives us the maximum profit. First of all, this problem is an optimization problem. Why we are saying optimization? The result is always either minimum value or maximum solution value. Then that problem we technically called optimization problem. So the knapsack, it always demands the maximum solution value. So that's why the problem also called maximization problem or optimization problem. So our problem statement, once again I am repeating, we have some n number of items like item 1, item 2 and so on, item n. All items weight of all items, nothing but I equal to 1 to n, must be greater than our knapsack capacity labeled as some m. So that's why we feel this is a problem. Otherwise, all the items we are placed into the knapsack, we are going to get all the items profit. But that is never happened. In generally, the number of items weight must be larger than the knapsack capacity. So that's why we are going to be select some items from the given n set of items. Which items you are going to place into the knapsack? Those items profit must be greater than, must be maximizing. So which item we are placed into the knapsack, we are going to be maintain solution vector. The solution vector size is the given number of items. For example, n items we have and so on, n items. If the first item placed into the knapsack, then its solution vector value is 1. If the first item not placed into the knapsack, then its solution vector value is 0. So and so on for each and every item we are going to be take the decision either placed into the knapsack or may not be placed into the knapsack. If it is placed, its solution vector value is 1, otherwise its solution vector value is 0. Good. So that's why the 01 knapsack also sometimes called binary knapsack. So that means either we consider the whole item or we ignore the whole item. There is no fractional. So that's why this knapsack also called binary knapsack. So what is the total profit we are getting and what is the bag weight we have? So that also we are going to be specify with the help of the solution vector as well as the weight and profit. So already assigned the profit label is P and weight label is W and solution vector label is I. So the profit is nothing but profit multiplied with a solution vector for each and every item. So Pi into Xi, I must be 1 to n. Our aim is to maximize this profit. So this is our profit. And while getting that maximized profit, what is our limitation? The knapsack capacity. Nothing but which items we are going to be placed that weight and solution vector I equal to 1 to n. This value must be the weight knapsack, which items you place into the knapsack, those weight must be less than or equal to the knapsack capacity. And along these two constraints, these two are the constraints, and one more like our solution vector value is must be either 0 or 1. And what is the initial constraint? Sum of all items weight, sum of all items weight, sum of all items weight must be greater than our knapsack capacity. Then only we consider or we feel this is a problem. Otherwise itself all the items we are placed into the knapsack and we are getting as the profit. So these are all the, so with this equation we are going to find the profit, and with this equation whether the items which we place in the knapsack, the weight is smaller than or equal to our knapsack capacity or not, we are going to be check it. Now this is the problem statement. Now come to our 01 knapsack using dynamic programming. So here we are going to be use two approaches. The first method or the first approach is going to be set theory, used with the help of set theory. So I am going to be maintain each a pair with two values or labels. First label or a value is nothing but the profit as of now, and also the weight. So in this way we are going to be maintain the pairs as a set, and initially we have the one pair, so that initial pair we called as S0, nothing but our items are 1 to n. Initially there is no item, there is no profit, so that's why that is our initial set. What is the first value? Profit. So initially what is the profit? 0, because our weight is 0. That means initially no item placed into the knapsack, that's why we didn't get any profit, and also the knapsack weight is 0. And next, this is the initial. The next we are following the recursive approaches or iterations. Now I am going to be place to think about to place the ith item. When I want to place the ith item, my aim is up to now what is the set I have, that is nothing but Si minus 1. For that set I am going to add the ith item weight and profit. Nothing but in my pair I know the first one is the profit Pi, and the second one is the weight, nothing but the Wi, present item I. So that is nothing but ith item profit as well as ith item weight. Here the plus indicates the addition. Simply we are going to add the previous set profit along with this item profit, and also previous set weight and also the corresponding item weight. Simply we are going to add. So what we are getting, that is not the ith item set as of now. So we are getting, if ith item has added into my set, that is the one set we are getting, that is not the full result. So that's why we are going to be assign S power I with some label 1. That is indicates some partial result. It is not the full result, but we need the full result. So the full result we are going to be obtain with the equation like, this is also recursive, S power I, nothing but the up to the previous set. Up to the previous set is nothing but Si minus 1 plus the present set. Present set is nothing but after adding the ith item to the previous set. After adding the ith item profit and weight is given by which set? Si1. So when you are going to be get this one, that is nothing but Si equal to Si minus 1 plus Si. So in this way we are going to be find all the possible sets. So my dear, please so typo Si equal to Si minus 1 plus Si suffix 1. Here plus indicates the merging, nothing but the previous set is going to be merged with after adding of present item weight and profit. So once you merge, you find with the ith item. If I is the lost item, then we find all the sets. While finding the sets, here we want to observe the two things. The first thing is, in a pair, what is the weight we are getting? That weight must be less than or equal to the knapsack capacity. If it is larger, then what is that means? If our knapsack weight is some 10 kgs, but we are going to be form a pair with 11 kgs, 12 kgs, 13 kgs. Is it possible to place 13 kgs item into the 10 kgs knapsack? Not possible. So that's why if W is less than or equal to M, then only we are going to be consider that pair. Otherwise, that pair must be removed from our set. That is the first thing we want to be observed. And the second thing, so in generally, whenever weight increasing, profit also must be increase. If weight increasing, the profit must be increase. Then the profit must be increase. If any pair, the weight increase, the profit decreasing, that pair we are not going to be maintaining in our set. Simply we are removing that set. That pair is dominating all other pairs in the set. What is that meaning? When weight increasing, the profit must be increased. When the weight increasing, profit decrease, such a pair we must be removed from our set. That we technically call purging rule or dominance rule. So I will explain that with an example. So for example, we have 3 items and the weights are 2, 3, 4 and profits are 1, 2, 5 and our knapsack capacity is 6. So initially I am going to check what is the 3 items total weight. 2 plus 3 plus 4, nothing but 5 plus 4, 9. So 9 is greater than my knapsack capacity or not. I am going to check what is my knapsack capacity, 6. So that means, so weight of each and every item sum greater than my knapsack capacity. That is our initial condition. If it is true, then only we consider that is a problem. Otherwise all items we are going to place into the knapsack. Yes, 9 is greater than 6. Yes, we feel this is a problem. So now I am going to be write once again here for we have the 3 items, profit and weights. What is the profits of 3 items? 1, 2, 5. So 1, 2, 5 and weights are 2, 3, 4 and knapsack capacity is 6. So 2, 3 and 4 have knapsack capacity is 6. So I must be first create the initial set. Initial set is nothing but S power 0. What is S power 0? 0 profit with a 0 weight. So then I am going to be consider S11. What does that mean? Now for the earlier set, what is earlier set? S1 minus 1 plus the current item. What is the current item? 1. So P1 and W1 I am going to add. So what does that mean? S1 minus 1, nothing but the S power 0 set added with P1 and W1. What is the P1? 1. What is the W1? 2. So 1, 2 I will add. Now I am going to be check what is the S0 set? 0, 0 plus what is the P1 and W1? 1, 2. So what is the final set I am going to be get? 0 plus 1, 1. 0 plus 2, 2. So this is the set we are getting. That is nothing but for the earlier set when I added the item 1, this set is formed, that is S1 suffix 1. Now I am going to be find up to the item 1 what are the sets it having. So that is nothing but S I minus 1 merged with S1 suffix 1. So what is the S 1 minus 1 s power 0 set merged with s power 1 1. So what is the s power 0 set? What is the s power 0 set? 0 0. Merged with, here not the meaning of addition my dear, plus indicates merging. So which set we are getting? S11 1 2. So 1 2. So what is the total set I am getting? This set having one pair and this set is the one more pair, nothing but two pairs, there is no duplicate, so that's why I am going to be get two pairs 0 0 and 1 2. So when I get this pair, what is the conditions? Two conditions. I want to check what is the weight here? 0. What is the weight here? 2. So those weights are larger than the knapsack capacity? No, those weights are smaller than the 6, less than or equal to 6. So that's why I am going to be maintaining two pairs. And what is second pair? Here what is the weight? Weight increasing, 0 to 2, weight increasing, profit also increasing. So that's why dominance or purging rule is not possible to apply for the S1. So after finding the S1, I am going to be find now S2. So how I am going to be find the S2? With the help of S1. So now I am going to be find S2 with 1. What is S21? S2 minus 1 set added with second item profit and weight. What is second item profit and weight? 2 3. 2 3. So I am going to be consider that 2 profit and 3 weight. So now what is the S2 minus 1? Nothing but the S1. What is the S1 set? It having 0 0 1 2 plus what is the profit it having? 2 3 corresponding item. Now what is this value we are getting? 0 plus 2 2, 0 plus 3 3. That is a one pair, comma 1 plus 2 3 and 2 plus 3 5. So this is a one more pair. When you are getting this pair, you must be observed. What about the weight? Less than 6? Yes. Less than or equal to 6? Yes. What about the second condition? Weight increasing, profit also increase. Yes, dominance rule is not possible to apply. Now once you find the set, then you can find the S2 set. So what is the S2 set? S2 set is S2 minus 1 set merged with S21 with 1. What is the S21? S2 minus 1, nothing but S1 set merged with S21. What is the S1 set? We know 0 0 1 2. Good. So set 0 0 and 1 2 merged with, what is this set? 2 3 3 5. So that is then nothing but what is the resultant set? 0 0 1 pair, comma 1 2 one more pair. I am going to be write weight increasing order. So that's why for the our dominance rule checking is basic. And the next one is 2 3 and the next one is 3 5. Now check what is the weight increasing? Yes. What about the profit? Profit also increasing? Yes. So we get the S2 set. Now with the help of this S2, I am going to be find now S3. So S3 final not possible to directly evaluate. I must be find S31. Good. So I am going to be first find S31. So S31. So that is nothing but S2 set added with third item profit and weight. What is third item profit? 5 4. So I am going to be add 5 4. So that is nothing but 0 0 1 2 2 3 3 5 added with 5 4. So what is the resultant we are getting? So now we are going to be get the resultant as 0 plus 5 5, 0 plus 4 4, 1 plus 5 6, 2 plus 4 6, 2 plus 5 7, 3 plus 4 7, 3 plus 5 8, 5 plus 4 9. So this is S13. So what we are going to be doing here, we must be verify those two conditions. What is the first condition? So now check weight less than or equal to knapsack capacity, nothing but the less than or equal to 6, 4 less than or equal to 6, 6 less than or equal to 6, 7 not the less than or equal to 6, no need to be maintain this pair, 9 not less than or equal to 6. Now I try to merge. Now I try to find S3 set, final set. We have the 3 items only, so the final set is S3. What is S3 set? Earlier set, this one, merge with these two. So I am going to be write directly 0 0 1 2 2 3 3 5 5 4 6 6. Okay, so now check it. First constraint we already verified. Second constraint, nothing but the dominance rule we are going to be check. So weight increasing, yes. Weight increasing, yes. Weight increasing, yes. Weight increasing, no. This is a question for us, because here the weight is 5 and here the weight is 4. So then think about the profit. What about the profit for this 3 and this one 5? Now observe, weight decreasing, profit increasing. So now for the 5 weight, what is the profit we are getting? 3. For the 4 weight, what is the profit we are getting? 5. So that means this set is not following the property clearly. Nothing but weight is not the increasing, decreasing. Profit must be decreased. So that's why this set, this pair does not follow. So that's why we feel this is a dominating within the set. So we must be remove this set. So then go for the next one. 4 to 6, yes. 3 to 4 increasing, profit also increasing. 4 to 6, weight increasing. What about the profit? Profit also increasing. So now we are stopping it. We find all the sets. Now within that set, what is the final pair? 6 6. That indicates that is the maximum profit we are getting. With maximum profit is 6, with the weight is 6. So as of now we find the answer, but our aim is to find the solution also. How we are going to be find the solution? For the solution, you must have a think which pair you finally find. That pair belongs to S3 and not belongs to S2. That pair is belongs to S3 and does not belongs to S2. So what is that meaning? I write the generalizing formula. So the final item which we are getting, nothing but the profit and weight, belongs to Si and does not belongs to Si minus 1. Then solution vector of that corresponding item is 1. Otherwise the solution vector value is 0. If it is 1, then I must be update the profit and weight. What is the profit as of now? P. What is the weight as of now? W. Which item you considering? Ith item. Nothing but ith item profit and ith item weight you must be subtract. So after adding, you must be update the profit and weight. The previous profit is pre. From that we are going to be subtract the current profit, current item profit. And as of now the weight is W and you must be subtract the current item weight. So once again you can recursively follow P minus Pi comma W minus Wi belongs to Si minus 1 and does not belongs to the Si minus 2 and so on. So this is the finding the solution. Now we are going to be check for this solution with the help of these formulas. So now what is the final pair we are getting? 6 6. So I am going to be write here 6 6 6 6 6 6 belongs to S3. Yes, I am going to be check does not belongs to S2 or not. S3 having 6 6 and S2 not having 6 6. Yes, the condition true. When the condition is true, what is the item now? 3. Nothing but x3 is 1. If x3 is 1, what about the profit and weight? You must be update. What is the third item profit? 5. What about the third item weight? 4. You must be subtract it. Nothing but 6 minus 5 and 6 minus 4. You are getting the new pair. What is the 6 minus 5? 1. What is the 6 minus 4? 2. So you are going to be check for the next item, nothing but I minus 1. 1, 2 belongs to S2 and does not belongs to S1. We are going to be check it. If it is true, then only x2 equal to 1. So S2 having 1, 2, yes. S1 having 1, 2, yes. The condition is false. When the condition is false, what about our x2? 0. If x2 equal to 0, no need to be update the profit and weight. You consider the as it is. Nothing but the same. 1, 2. We are going to be check. Belongs to S1, I minus 1. That is our I now. 2. 2 minus 1, 1. Yes. And not belongs to S0. Now check it. What about the 1, 2? Belongs to S1. Yes. And what about the 1, 2 belongs to S0? No. S0 having only 0, 0. Not belongs to. So what is that means? The condition is true. When the condition is true, then what about our x1? 1. Now, what is the thing we are going to be do? Corresponding item profit and weight, we must be subtract. What about the P1 profit and weight? 1, 2. We are going to be subtract that 1, 2. So, 1 minus 1, comma, 2 minus 2. What is the 1 minus 1? 0, comma, 2 minus 2? 0. Nothing but we reach the base case, we are stopping it. Now, what is our solution? Vector x, nothing but 3 items we have. 1, 2, 3. What is x1? 1. What is x2? 0. What is x3? 1. So now observe manually. What is item 1 weight? 2. Plus what is, which items you consider? 1 and 3 only. 1 and 3. What is third item weight? 4. What is the total weight? We are getting 6. What is the final pair weight? 6. So that is our knapsack capacity also. What is the profit we are getting? What is the first item profit? 1 plus. What is the third item profit? 5. Nothing but 6. So that is the profit we are getting. So manual checking also we are going to be do like in this way. Now in this way, if you follow this set theory approach, then what is the time complexity? The time complexity is nothing but each and every item. If you have the 2 items, nothing but the 1 item like x1, it may be considered, may not be considered. If it is x2 also, nothing but x1 and x2. So that means the items are second item considering, first item also considering. Second item considering, first item not considering. Second item not considering, first item considering. Both items are not considering. So which is look like? So the combinations of 0, 0, 0, 1, 1, 0, 1, 1 for the 2. If it is 3, we have the 3 items like x3 also. Then the possibilities are third item not considered, second item not considered, first item not considered. Third item not considered, second item not considered, first item considered. Like the all possibilities. What is that mean? Which is look like each item having either considering or not considering. Nothing but the binary 2 power of n. So this is our state space set tree. Nothing but the set, the maximum sets we are getting that. That means what is the time complexity of this one? Order of 2 power n by using set theorem idea. And also what is the space it demands? All sets, nothing but the order of 2 power n. So this is the approach 1. I hope you understand the method 1. Method 1 is nothing but the set theory. So once again I am recalling the set theory. So initially we form one set, that is a s power 0 set. There is no weight, the profit. So each pair we are going to be maintained in the form of 2 variables. First variable or first value gives us the profit, and second variable or second value gives us the weight. So that is the initial case. And for the recursive, for the each and every item, the earlier set going to be added with the present item weight as well as the profit. Now we are getting the s power I suffix 1. Once you find that ith item adding profit and weight pairs, those are all pairs must be merged with the existing pairs. So that will be given by s power I set. So these two are the recursive. So the recursive up to our ith item is nothing but the last item, nothing but I equal to n when we are getting. Until that we are going to be repeat our procedure. So while getting the sets, we must be observe the two things here. The first thing is when the new pair forms, that what is that pair weight. If that weight is exceeding the knapsack capacity, simply removing that pair, no need to be maintained. The second one is when the weights are going to be increasing in the sets in each and every pair, the profit also must be increasing. Otherwise, which pair having the more weight, less profit, that pair we must be removing from the set. That will be given by the rule, dominance rule or purging rule. This is about the set theory concept. For this one, what is the time we are going to be maintain? Order of 2 power n, and the space also order of 2 power n. So to overcome this time, we are going to be use the second approach. The second approach is the fully tabular method. So in this tabular method, first we are going to be maintain the table size with rows are the number of items plus 1. If you have the n number of items, the rows are n plus 1, and the columns are, if our knapsack capacity is W, we are going to be maintain the columns are W plus 1. So that is our table size. Once we formed a table, we are going to be verify all the items one by one. If what is the first row? First row is nothing but no item in my bag. When there is no item, if the 0 case weight, what is the profit we are getting? 0. 1 weight, 0, because no item is there in my bag. When there is no item in my knapsack, it must be gives us a profit as 0. For the second row, I am going to be insert the first item. Only first item I am going to be considered. For example, I am going to be increase my number of items compared to the earlier example. So here my number of items are 6, like so 1, 2, 6, and corresponding weight and profit. Now observe, when I going to be fill for the second row, I am going to be consider the only first item. What is the first item weight? 1. That means less than 1 unable to place the item 1, because I am talking about 0, 1 knapsack. So either it consider the full item or we must ignore the full item. So that's why I am going to be consider item 1. Item 1 weight is 1 up to 1, nothing but before that 1 unable to place that item. So that's why up to that item 1, before that all weights are 0. And when my knapsack capacity is 1, yes, I place the item 1. When I place the item 1, what is the profit I am getting? 6. The second row talks about up to the only first item. There is no second item. So I place the full item and unable to place the other items because I have the only item 1 as of now. So that's why even I have the free space in my knapsack, unable to place the other items. So that's why I get the only profit as 6. Now go for the next row. When I go for the next row, that means now I am going to be considered up to second item. Up to second item. What is it meaning? I am going to be considering item 1 or item 2 or both. Yes. What is the item 1 weight? 1. What is item 2 weight? 2. So which is minimum 1? Up to 1 I am unable to place the any item. So I didn't get any profit. Now when I go for my knapsack capacity is 1, yes, it allows to place the item 1. When I place the item 1, what is the profit I am getting? 6. Now go for the next knapsack capacity. Now what is my knapsack capacity here? 2. Now what is my second item weight? 2. Is it possible to place the item 1 and item 2? What is the total weight? 1 plus 2, 3. So unable to place 2 items. Is it possible to place only item 1? Yes. Is it possible to place only item 2? Yes. Now the question for us is, sir, which item I am going to be considered? My dear, we are talking about the maximization. So that's why you must have a think about the maximum of either 6 or 11 profit. Which is the maximum? 11. So that's why I am going to be placed the 11. Earlier for the 2, what is the profit I am getting? 6. But now what is the profit I am getting? 11. Good. Now go for the third. My knapsack increasing. What is my knapsack capacity now? 3. So what is the first 2 items weight? 1 plus 2, 3. Yes, that means item 1 and item 2 both are possible to place into the knapsack. Now I place the both items. What is the profit I am going to be get? 6 plus 11, 17. 6 plus 11, 17. Now what is the profit I am getting as of now? 17. Now I place the 2 items. There is no third item because how many items I am going to be considered as of now? The limit is only 2 items. I place the 2 items. The profit is the same, even I have the more knapsack free space. I hope you understand it. Now go for the next row. Next row is nothing but I am going to be think about up to third row, nothing but fourth row, nothing but up to third item. Up to third item is nothing but I am going to be considered up to this. Now check it. What is the minimum weight? 1. So that means not possible to place the any item 0. What is the next one? 1. What is how many items are possible to place? Only 1. What is the profit it gives us? 6. So next one. What is the next way? Knapsack 2. How many items are possible? Only 1. Either item 1 or item 2. Item 3 weight is 4. Not possible to place item 3. Either item 1 or 2. So maximum of profit 11. So that's why. Then go for the 3. 3 also not possible because the third item weight is 4. Up to 4 unable to consider the item 3. Now we have the right to consider the item 3. Good. Now consider. What is item 3 profit? Only 1. As of now, what is the profit you are getting? 17. What is the maximum? 17 or 1? 17. 17 only. Then go for the next possibility. What is our knapsack capacity? 5. Nothing but it allows item 1 only, or item 1 and 2, or item 1 and 3. What is item 1 weight? 6. What is item 2 weight? 11. What is item 1 and 2 weight? 17. What is item 1 and 3 weight? 6 plus 1, 7. Which is the maximum? 17 only. So I am going to be consider the 17. So if you have any doubt, please observe the sixth one. Now your doubt is going to be clarified. So what about this knapsack capacity? 6. So 6 allows item 1 only itself, item 2 only itself, item 3 only itself, item 1 and 2, and item 1 and item 3, item 2 and item 3. Nothing but item 1, 2 also allow, item 1, 4 also allow, item 2, 3 also allow. Unable to place all because what is the all items weight? 7. What is our knapsack capacity now? 6. So now I am going to be checking the maximum of this all. What is the maximum? 17 only. So I am going to be get item 1 and 2, 6 and 11, 17, 7. Now next knapsack capacity is 7. For the 7, what is the total items are possible to place? Yes. What is the total items weight? 1 plus 2 plus 4. Nothing but the 7. Yes. What is the profit we are getting? 80. Here also 80. So in this way, next I have considered up to 4, up to 5, up to 6. So when I consider those are all, next my table is look like this one. This is my table. So if you clearly observe how I am going to be fill this table with the help of one equation. That equation is like this one. When I am talking about when I am talking about the ith item, I nothing but the row, W nothing but the column. So for which item weight it having, that weight must be my minimum knapsack capacity, otherwise unable to place that full item. So that's why I am going to be check when I am at the ith row, what is the cost up to the previous row, and before I place that corresponding item, corresponding item is nothing but I, weight is Wi, profit is Pi. My dear, profit also sometimes called as value. So that's why either Pi or Vi. So my knapsack capacity is W. So W minus Wi, if I have some value, then I am going to think. So when I am talking about the ith item, I must be consider I minus 1 item only. So that's why what is the cost of I minus 1 with W minus Wi? That cost added with the present item profit. What is the present item profit? Pi or Vi. So this is the one value, and one more value is the same of the earlier item up to the W. Nothing but I am not including the current item weight is Wi. I am not including. When I am not including, what is the value I am getting? W only. So previous row is nothing but I minus 1. I am going to be check it, which is the maximum, that only I am going to be SI. So that is a recursive equation we are going to be use. So with the help of that recursive equation, we are going to fill this table. So finally we are getting this table. So my dear, we are getting the result. What is that result? What is the answer? We are getting the maximum profit as 30. But our aim is to find the solution also. Now we are going to be find the solution with same as the previous set theory. What is the formula we are following for the set theory? The same. So the profit must be belongs to S6 and does not belongs to S5. Now observe 30 S here. Here also 30 yes. That means the condition false. When the condition false, I am going to be write the solution vector for it. So I have the 6 items. So that's why my solution vector size is 6. 1, 2, 3, 4, 5 and 6. What is the 6th one? Always the solution vector is going to be full in the reverse order. So what is the solution vector? 0, because the condition is false. So now you can be apply. So 30 is belongs to S5 and 30 does not belongs to S4. Check it. Yes. 1 does not belongs to, that means we consider that item. Which item we consider? 5th item. Once you consider, what you are going to be do? That corresponding item profit you must be subtract. Yes. What is the 5th item profit? Check it. What is the 5th item profit? So we have these items. What is the 5th item profit? 19. So what is the value of 30 minus 19? So 30 minus 19 is 11. So that means 11 belongs to S4 and does not belongs to S3. We are going to be check. No, condition false. So then what we are going to be do? 11 belongs to S3 and 11 does not belongs to S2. So this is this one, this is this one. So no, condition false. So then what we are going to be do? Once again we are going to be check. The 11 belongs to S2 and does not belongs to S1. So 4, 3 already not included. Then think about the item 2. 11 belongs to S2? Yes. 11 belongs to S1? No, not belongs to S1. So we are going to include that item. when you include that item profit we must be subtract. What is the weight profit as of now? 11. 11 minus what is second item profit? 11. 11 minus 11, 0. Now we will check it. So 0 belongs to S1 and 0 does not belongs to S0. False. When the false, x1 also not possible to place. Already we reached the 0 item, we are stopping it. So then this is our solution vector. So in this way we are going to be find the 0-1 knapsack problem or solving the 0-1 knapsack problem by using tabular method. Now what is the time complexity of this tabular method? Observe, what is the table size? N plus 1 into n plus 1. What is the higher term we are getting? N square. Now what is the time complexity of this one? Order of n square. What about the space complexity? The table size like order of n square. What is solution vector size? Order of n, which is higher term n square. So that's why I'm going to be say my space and time is the both order of n square. So this is the algorithm for this one and this is the algorithm for same theory. Okay, so thank you one and all.